The topic we're going to cover right now is solution stoichiometry. Recall that we typically use molarity to represent molar concentration of solutions, big M. Molarity is a ratio of the moles of solute to liters of solution. Remember that at the end of Chem 2, we were solving solution stoichiometry problem. What volume of 0.2 molar sodium hydroxide is needed to react with 35.0 milliliters of 0.175 molar sulfuric acid? The first thing that we need to do is to identify what ions are in these compounds. So sodium would be Na+, hydroxide, OH-, with sulfuric acid, which must be H+, and SO4, 2-. So the first thing we're going to do is write a balanced molar equation. We're going to react NaOH with H2SO4. This is a double replacement reaction, so we'll have H2O as a product and Na2SO4 aqueous. First, we need to make sure that our reaction is balanced. We have two NAs on this side, so give this a 2. 2 of these, H2, that should be balanced. And now we need to identify what this problem gave us. So we don't know milliliters of NaOH, but we do know it's 0.250 molar. Sulfuric acid, we have 35.0 milliliters of 0.175 molar. Our strategy here is going to be to start with milliliters of H2SO4, convert it to moles of H2SO4, then we'll convert it to moles of NaOH, to milliliters of NaOH. Using the tools we had learned last mod, we'll go from milliliters to moles. We'll be using the molarity of H2SO4. We'll use the mole ratio from our balanced equation to get from moles of H2SO4 to moles of NaOH. And last but not least, we'll be using the molarity of the NaOH to convert between moles of NaOH to milliliters of NaOH. To start, we'll look at our compound that we have all the information for. 35.0 milliliters times 10 to the minus third. We'll convert to liters. Milliliters cancel. Multiply by the concentration. Use the mole ratio from our equation. We know that the H2SO4 has to cancel, so it goes on the denominator. And then we'll convert from moles to liters using our molarity of NaOH. Then we'll convert back to milliliters. We should get an answer of 49.0 milliliters of NaOH. And more specifically, it's 49.0 milliliters of the 0.250 molar. So first, we'll do this next problem together, and then we'll have you do the second one on your own. First things first, we have to identify what ions are in our written compounds. So we have barium, which would be Ba2+, hydroxide, OH-, will react with hydrochloric acid, H+, and Cl-. Putting these together, we have BaOH2 plus HCl goes to H2O plus BaCl2. We need to make sure that our reaction is balanced. We see we have 2 Cls on this side and only 1 on this side. So we'll put a 2 here. It means we have 2 H's, and remember that H2O can be written as HOH. We put a 2 here. Everything should be balanced. Now, we can identify that we are solving for the amount of milliliters of barium hydroxide. It has the concentration of 0.0500 molar. HCl is 25.00 milliliters with a concentration of 0.200 molar. Remember that big M equals moles per liter. Once again, we start with 25.00 milliliters of HCl. convert it to liters, then use the concentration of HCl, use the mole ratio to convert to moles of BaOH, and then we'll multiply by the concentration. We'll need to multiply by the liter conversion to get 50.0 milliliters of 0.0500 molar NaOH. We'll take this moment to pause. I want you to try out the second problem and then press play when you're ready to compare. All right, now that I have the setup, I'm going to show you that the answer is 27.5 milliliters of NaOH. If you did not get this answer, take another moment to pause, check your work, see if you can get that answer. And then if not, I'll show you the work in a minute. All right, there you have it. In this next problem, you're given the equation, so we can just start by writing down all the information from the problem. So we have 0.720 grams of kpH with a molar mass of 204.22 grams per mole. Is transferred to an Erlenmeyer flask and dissolved in deionized water. The sample was titrated to a faint pink with 34.05 milliliters of NaOH. What is the molarity? And as you'll see, the answer's right here. So if you get that answer, try to see what you got wrong. So remember that we're solving for molarity, so we're looking for something with the units of moles per liter. In order to solve this problem, we're going to start with 0.720 grams of KHP. We're going to convert that to moles using molar mass. We're going to use molar ratio to convert from KHP to NaOH. And this is going to give us an answer of 0.00353 moles of NaOH. And we must remember that molarity is moles over liters. So if we divide that by our milliliters, but in liters, which is 0.03405 liters, we're going to get a final concentration of 0.104 molar NaOH. All right, it's your turn. Pause the video. If you don't get it, check your answer. And then if you're struggling, then press play and compare the answer. All right, to walk you through the answer, we convert from milliliters to liters. We go from liters to moles using our molarity. We use mole ratio to go from moles of NaOH to moles of HCl. Then we divide those final moles of HCl with the volume of HCl that we use to get our molarity.